Hi there. In the series of 16 major losses, let us today discuss on cutting tool replacement losses. Under 8 big equipment losses, we have already discussed breakdown losses and setup and adjustment losses. So in continuation to that, today we will discuss cutting tool replacement losses. Whenever a machine is stopped to replace cutting tool like inserts, grinding wheel, blade, cutting wire. So the time lost in replacing that cutting tool is counted under cutting tool replacement losses. Whether it is a wear and tear or a accidental replacement, that will be counted in cutting tool replacement losses. Normally it is measured in minutes. So how to reduce cutting and replacement losses? Of course we cannot make it zero, but we can minimize it. Tool replacement has a significant cost impact and it hits profitability of organization. So you should make effort to minimize the cutting tool replacement cost. For addressing cutting tool replacement cost, you should first analyze present situation. What is happening right now? So you should analyze is there any standard operating procedure for replacement of cutting tool, and what variation you are getting with respect to standard operating procedure. Is there any relationship between wear of cutting edge with respect to depth of cuts or number of cutting cycles? You should record each and everything. Whether the tool is breaking or it is wearing out, and what is the frequency of that breakage or wear. So you need to record minimum 3 days data and analyze the mounting of cutting insides, tool holders, their firmness, their rigidity, and their accuracy. Is there any relationship between wear of tool with respect to surface roughness? So it is advised that you form a team, so you do parallel activities to record all this data. So once the data is recorded, so you will have a clear picture what is happening right now. So this data will help you in knowing the current situation of failure, whether the tool is wearing out due to depth of cut, or whether it is wearing due to surface roughness of input material, or even while cutting, when surface roughness increases, then it wears fast. Number of cuts. So basically you will have an idea of what is happening right now, what is the behavior of cutting tool which tends it to fail. So now next step is to analyze current cutting condition. The study and record what are the cutting feet and speed being used right now. Compare those cutting feet and speed with the standards, with the cutting standards, or maybe the manufacturer of the cutting inserts nowadays give band of feet and speed in which their tool will optimally perform. So compare current cutting feed and speeds with the cutting standards, and parallelly also analyze shape of tool and their cutting debris, what kind of chip they are forming. Analyze chip breaker, so whether it is as per standards, and along with cutting feed and speed, analyze the tool holders. Just analyze how the mounting methods, is it firmly securing the cutting inside, is the correct tightening torque being used, see the dynamics and statics of mounting. So while cutting, what kind of force is coming on the inside, see the rigidity of tool holder, see the coolant flushing, coolant concentration, flushing out of chip breaker. So note down all these points. So till now you have analyzed all basic conditions like behavior of wear and tear of tool with respect to different conditions, with respect to cutting feed and speeds, and with respect to surface roughness, with respect to depth of cut, and basic condition like coolant, flushing, tool holder. So all these basic condition you have recorded. Minimum period is 3 days and more is good. The more you data collect, the more better analysis comes out. So now next step is to restore the deteriorated condition from your analysis. When you will analyze all these things, definitely you will find many things which were away from the standard operating conditions. So next step is to restore all those conditions to basic conditions. Take trials of different cutting feed speed combinations, see where you get the optimum cutting tool life, check the concentration of coolant, reverse it, see the cutting tool shape. If over a period of time someone might have changed the standard shape to different some other shape due to some cost benefit without analyzing. So you just restore the standard cutting conditions. So first step is, after analyzing all above three, you have to restore standard cutting conditions. So after this, next step involves expert involvement. So after restoration all basic conditions of cutting tool, now you need to go for some advanced actions, that is vibration measurement. So get the raw waveform monitored. You will be requiring vibration analyzer for this. There are agencies which will do this for you. You have to analyze different frequencies of equipment while cutting and even while in normal condition. So you have to also examine the vibration of surrounding machines also. So get the notes of rotational frequency, peak frequencies, frequencies while cutting. Get the frequencies recorded for different rotational parts. Correlate these vibrations characteristics with respect to cutting conditions. At different cutting conditions, what vibration notes you get, what frequencies you get. Measure the natural vibration of the equipment. Note down the conditions where you get minimum vibration. And the next step is do technical analysis of electric current. Study motor rating and its load for spindle motor, and then check the pattern of increasing of current with respect to usage of tool, that is number of parts being made by a tool. So record the pattern of current, how it increases with the wear and tear, and check the relationship between number of part made and effective power being used by a spindle motor. So this will give you an idea of pattern of wearing the tool. So once you get the data of vibration measurement and electric current, so now it is time for restoration and taking countermeasures. For abnormal vibrations in natural conditions, get the equipment restored. For vibrations in cutting conditions, experimentally make a combination where you get lowest vibrations with optimum cuttings parameters, optimum depth of cut, optimum fit and speeds as per inside speaker recommendation. Prior to this, you must get the equipment restored to lowest frequencies of vibration for its natural operation. Once the equipment is restored, then only you have to do that experiment of combination for vibration versus cutting. Similarly, for electric current and effective power of motor, please verify it with the motor capacities and process requirement of cutting feet and speed. If they are matching, continue with this. If it is not matching, means that motor is not enough to meet all those requirements, you should think of shifting the operation to some other machine which meets the power requirements. Apart from this, nowadays machine have facility of current measurement. You can link the motor current with the tool monitoring system. Machine can give alarm when current goes beyond a specific limit. Also, there is a concept of sister tooling. For example, you have VMC, HMC, or even turning center. So you have 24 pockets, 20 pockets, or even more pockets in your machines. And if you have spare pocket, you can use a sister tool in the magazine and program in a macro that after this much of time that n number of tool will be called and you will get a tool offline to replace the insert. So this will zero down your replacement time. So in this way you can optimize cutting tool replacement time to bare minimum to reduce the cutting tool replacement losses. Thank you very much.